So today we can discuss this question from LeetCode, May LeetCoding Challenge, Problem 7, Cousins in Binary Tree. If you like this video, please hit the like button and subscribe button. So in this question, it states that in a binary tree, the root node is at depth 0 and the children at each depth k node are at depth k plus 1. Okay. Two nodes in a binary tree are cousins if they have the same depth but different parents. So this is the most important line in this question, and if you understand this, the question is very simple. So two nodes in a binary tree are cousins if they have the same depth but have different parents. Okay, so you're given the root node of a binary tree with unique values. The value x and y are of two different nodes in the tree. Return true if and only if the root nodes corresponding to the values of x and y are cousins. So as you can see, in this binary tree, if they're given 4 and 3, 4 and 3 are not cousins because though they are from different parents, but they are not at the same depth. Okay. In this binary tree, 3 like 5 and 4 are on the same depth and are from different parents, as you can see. So yeah, you have to return true. So in this, they are asking for 2 and 3. 2 and 3 are from the same parents, so you have to return false. Okay. So I hope you understand the question first. Now, the logic can be very simple. You just have to find out the depth of our node, which we want to find out, and the parent of our nodes, of the two nodes. So if the parents are same, we have to return false, or if they are at a different depth, we have to return false, else we have to return true. So we just have to find out or write a function such that we can find out the depth and the parent at the same time. But how can it be possible? So we can iterate from the start. So this can be done using two ways. First, you can also write a level order traversal in a tree in which you can make two queues, and whenever you move from one level to another, push all the leaf or like all the nodes in one queue and check whether the two nodes which we want to find out are adjacent. If they're adjacent, which means like this and this two, when we push them in a queue, they will be adjacent because it's a binary tree, and we can find out whether they are from the same parent or not while pushing in the queue only. If they are, and because level order traversal always give the answer in the same depth, so we are ensuring that they are the same depth. But if they are from the same parent, we have to return false. Else, if we find out two leaves, two nodes which we want in the final answer and they are at the same depth, we have to return true. But I am not doing that level order traversal. You can see videos on level order traversal and it will be more clear to you. I will just be doing the recursive one, and in which I will write the function in which you will have to find out the depth and the parent of a node at the same time, and then you just have to return whether they have the different parents and at the same depth. Okay, so what, like the main thing which we can do is we have to find out the depth. So we'll write x depth for the depth of the x node, and and, and y depth for the y node. Okay, now I have to find out the parent of x, and it will return the parent of x, in which I'll write a function depth in which I will send root the x node value because we are starting at depth 0, and we will have to find out our depth, x depth. So we'll also send x depth in this function, but we'll send the address of it so that it will change along the function, and we'll do the same for y. You will understand more when I write the function depth, in which I'll send the y parent, and yeah, and we have also have to send this y root y. Okay, so now our final condition will be if x parent is not same as y parent and x depth is equal to y depth, we have to return true. Else we have to return false. I hope you understand till now. So now let's write the depth function. In the depth function, what you'll have to do is you have to return a tree node, because as you can see, we are receiving a tree node which is actually the parent. So in this function, we are finding out the parent of this value which are sending, the x node. So tree node depth, what we are taking as the inputs, we are taking tree node root, we are taking so we are taking x, or I can take it as value. We are also taking in height, and we are taking it the depth. It's not actually the height, but we are just taking it as h. So the first in every condition, in every like tree node recursive function can be if the root is null. Just write this, and if you just have to return null, because we have to return a tree pointer. Okay. Now there can be a condition. So what we are actually doing is, when we are at a root node, when we are at a node like such suppose, we have to check whether this will be a parent such that its left child exists and it has the value which we are wanting it to be. Like, we are finding out whether x is the left child of this node. So for any node, we'll check whether its left child exists and its value is equal to what the value we are finding. This is our parent and this is our like the depth. So depth is, we are at the parent, so plus 1. So depth of our parent plus 1 is the depth of our child, and if the left child exists of any node and it's equal to our value, we return the root node because that's our parent. If our right child exists and that's our value, we return the right. Okay, so that's the main logic we are using here. So if root left exists and root left val is equal to r val, which we are finding out, then because d stores the x depth, so at this only point we'll have to find store that the depth of our root, like the value which we are finding is h plus 1, which I've told you. If we are the parent, the depth of our child which we want to find out is h plus 1. H is actually the instantaneous or the like the depth at which we are, and this d is storing out the depth of our finding value, and then we have to return root, which actually is the parent. If root right exists and root right val is equal to val, then the same d is equal to h plus 1 and return root. If both of them are not true, then we have to move down our binary tree, and because they are returning our a root node, we have to take this at input L as depth. So for moving down, just like input the left node address and val remain the same, height increase by 1 because this is an instantaneous depth which we are at, and depth remain the same. Okay, and the same for right. Okay, now but if our L actually exists, so if we have not hit our value and this L actually stores our left uh, parent value and it exists, it's not null, so we have to return this L. And the same for height, because actually in the function, this is recursive function, we have to return out the parent value in the end, and when it calls it again and we don't return this value, then how will our parent value be sent out in the last? That's the whole function. Okay, so we can easily, like I can write it like this. That's it. Let's run this. Okay, we can also write turn null because this is a non-void function and we have to write something at the end. And yeah, giving the correct answer. Let's submit it. So it's accepted. I hope you understand the logic. I've made it very simple. If you still have any doubts, please mention down. Thank you for watching this video and I'll see you in the next one. Bye.